Hello, everyone. How are you guys? Thanks for sticking around for the last session of the conference. Well, we're going to end it up with a bang and it'll send you homes with like a lot of good info. So before I start, I just want to do a quick pulse check. How many of you guys are using AI today to generate your IAC configuration? Give me a hand check. All right, that's pretty decent. How many of you are using MCP specifically with that? All right, fewer. Okay, cool. All right, so my name is Gautam, and I'm a partner at C here at HashiCorp, and I'm going to take you through, automating your secure DevOps journey with MCPs. And the agenda for, the session is we're going to take a look at MCP as a concept in general. I know a lot of people talk about MCPs. I don't know if you've kind of really dived deep into it and see what it does and what it can do. So we're going to take a quick look into MCP itself. We're going to talk about Terraform MCP server. I know Armon kind of announced it earlier today in the keynote. We're going to take a look at the Vault MCP server. We're going to take a look at the capabilities and short demo of what it can do. And finally, end with the Radar MCP server. So getting into the MCP introduction. It's a protocol introduced by Anthropic last year in around November. It's really a way to provide a lot of good context to AI, right? So the responses and the activity that it does is much more smarter, right? The difference between, let's say, a general API and a MCP is that APIs were designed for software communication, not specifically for AI. MCPs, on the other hand, were kind of built from ground up for large language model, and it standardizes how LLMs, fetch context and use tools. So, what is the value and why should you sort of get into it, right? It can bring most of the complicated tasks that you might be doing already, like you might be doing all of those tasks manually today, and it can automate that with much more accuracy with natural language models, right? So let's look at some of the core concepts of the MCP server. It has tools, resources, and prompts. There are some other newer features that was kind of added to the spec later this year, but these are the fundamental kind of pieces of an MCP server. So tools are essentially a way to, if I have to use an example of APIs, tools are essentially post request, right? In Terraform world, like if you guys are much more familiar with Terraform, I'd say tools are more like Terraform resource blocks, right? So you're taking an action, you're performing an action, you're doing a post request, right? Resources are more like data source blocks in Terraform or a GET request in an API call. And prompts in that sense are more like stacks. We all heard about Terraform stacks. They're more like workflow recipes that you can kind of follow to achieve a specific task. So let's look at the MCP workflow. You have your AI assistants, like it could be like a Visual Studio Code, Cursor. Manu talked earlier about Q. You have your MCP server, which could run locally on your computer. It's a binary, it's a Docker image that just runs locally on your computer. Or it could be a remote MCP server that's hosted by one of the software vendors that does that. And then you have your own product. It could be any product that supports APIs, has files, has databases, right? So the coding assistant or AI host requests certain questions from the MCP server, and that request is sent via simple sort of JSON query. The MCP server then executes the tools or the API calls that it's meant to execute. It returns the data back to the MCP server, and then MCP server essentially formats it for the actual AI host to be able to understand it. This last step is, I think, more important than a lot of people give credit for, because you can essentially reduce context. Your API responses might be huge. You want to trim it down so that you don't bloat a lot of context in your models, right? So with that quick introduction out of the way, I'm going to talk about the Terraform MCP server and its capability. So for those who don't know, we released the Terraform MCP server, the first version of it, earlier in May. And it was primarily designed to work with the public Terraform registry. So if you work with Terraform, you might be familiar with the registry.terraform.io. That was its main usage and workflow. So the HCP Terraform workflow that we announced earlier today allows you to work with HCP Terraform and perform the same kind of actions that you would perform in HCP Terraform, like creating workspace, creating variables, attaching tags. And all of these workflows can be automated and done using natural language and automation. Like it makes your job way more easier than to kind of write scripts or do it manually or do a bunch of click ops. It also reduces hallucination because it has the right context, right? If you're looking for a documentation from a particular pinned version of a provider, the MCP server can get you the exact documentation of that version, right? LLMs are trained, in a 6-month block. There might be some providers that you're using that are not even published yet in the Terraform registry. It can have information about the latest provider that are just published, right? All right, so next, just look at what are the tools and resources that we've implemented in the Terraform MCP server. So you have a bunch of provider tools here. So you can, search provider documentation. You can get more details about each of those resources, figure out what they're planning to do. Here's the kicker. You can also do that with private providers and private modules. So if your LLM needs context on, if you have your own practice around Terraform, you have your own published modules using HCP Terraform or Terraform Enterprise, and you want the LLM to generate the code with considering those private modules in mind, the MCP server can help you do that. That is something that ChatGPT or like vanilla LLMs are not able to do, right? They don't have any idea about like what your infrastructure practices are, right? Then it can also look up and recommend, Sentinel policies. We have a lot of Sentinel policies in the Terraform registry, and I'll show that more in the demo. We've also implemented some resources. So when it generates those code, it adheres to the standard that we've set as HashiCorp for Terraform. So use particular file names, file structures, folder structures, all of those kind of goodness that we've kind of collected over the years with experience working with Terraform, we've added those as instructions. All right, so here's a quick snapshot before I kind of dive deep into the demo. Here's an example prompt. So I need help setting my Azure storage bucket, using Terraform. What are the steps that the MCP server is going to take? So it's going to first figure out, okay, I'm going to search the registry with some context. So in this case, it would be Azure storage bucket. And it's going to have a collection of document, because if you use Terraform, it's not just one page that you visit. You have to visit like interconnecting pages, because all resources are kind of shared within the registry. So it figures out the list of documents that it needs to kind of have to generate the right code. And then it consults multiple of those documentation to create that resource, right? It essentially figures out how to combine them and then generate a Terraform code for it. So let's look at this in action. So I have a VS Code agent here. I've set up my MCP server. I usually like to set up my MCP per workspace, so you can sort of see the MCP JSON file, so that I have individual sort of constructs for each of my workspaces. And what I'm going to ask it is, I need help setting up the GCP storage bucket. I just changed the prompt a little bit, but it'll essentially go through the same things. It created like 6 to-dos. It's looking at all the tools that it kind of needs to consult and figure out what is the best answer to produce that code. I sped up this demo a little bit just to kind of show the value, and I've kind of sped up all the demos. But you can kind of see it's creating the readmes, makefiles, all the quick start guides. And if we look at the input that it gave to the MCP server here, we'll see that not only did it consult like individual storage bucket documentations from the registry, but it also considered like a module, right? And again, this is all for now. This is all using the public registry. I'll show the private registry in the next demo. But here it consulted, okay, there's a module, and it figured out, okay, the best way to kind of deploy some of this stuff is just using resources blocks, right? So it captured some of those examples and demos. So now next what we're going to do is we're going to ask it, okay, you created a storage bucket for me. Can you recommend a policy based on the storage bucket? Can you figure out, okay, what policies do I need to attach to the storage bucket and apply them for me? So one of the things it figured out is, some of the bucket level access I've already kind of enabled the most secure way to kind of do this. But then there are other things that it missed. So it's figuring out, okay, I'm going to use the MCP server to query, policies that are available in the Terraform registry. I'm going to figure out the best policies, and then I'm going to add those files back to the Terraform. So as you can see, it failed a couple of times. It tried a couple of times to kind of search for the right policy, the right search query, and it finally found it at the end. And one of the other things that it does, it also looks at the CIS Sentinel policy that we've created, and it tries to emulate what it does, but for GCP. So it kind of gets some inspiration from those policies and attaches that to the Terraform here. All right. So now the second part. This is something that we just released, I believe, 2 days ago, which is working with Terraform Enterprise and HCP Terraform. So this is how the authentication works today in the MCP server with your TFE token or your HCP Terraform or Enterprise address. VS Code does this nice thing of prompt string. Essentially, you don't have to store your tokens in like clean text. What prompt string does is when you run the MCP for the first time, VS Code actually prompts you to enter those variables that it doesn't know, and then it stores it securely. You have similar things for other AI tools. If you're using, Amazon QDev or Cursor or Anthropic, you have similar workflows. So similar to the Terraform one, let's look at the tools that we've implemented for HCP Terraform. Here's some of the operations that you can do with the newer version of the Terraform MCP server. So you can search workspaces, you can get workspace details, like what kind of repositories are connected to, what kind of tags are it using, a whole bunch of information from workspace details, create workspace, update workspaces. And I was talking to one of the persons in the booth, and their use case was they wanted to know all their stale repositories in HCP Terraform. And I had a friend kind of try it out and look it up, and they were able to do it. So MCP servers provide you with essentially like Lego blocks, and you can create like Lego masterpieces from it. So your AI workflows, you can do a lot of like powerful things with it. So let's look at a demo for the newer version of the MCP server, which works with authenticated workflows. What I've done here, I've done something a little bit different. I've defined an agents.md file here. And what that file essentially does, it tells the agent or the LLM that there is a very specific way I want them to use the MCP server and generate the Terraform MCP server, generate the Terraform code, right? So one of the first thing I said is like, any Terraform that you generate, just add this backend, right? That's my workflow. I'm just going to use the cloud backend. Just add this backend to the code. I also said that before you search for any modules in the public registry, search in the private registry first. So let's take a look at how that looks like in action, right? The other thing that I also kind of said, like, hey, I want my repository and file structure to be in a way that I like to be, right? You might adhere to our standards, but you might have your own sort of Terraform practices. So I asked it to deploy an AKS cluster with a Mariner container host, right? This is a module that I've created, in my HCP Terraform account. It's not something that's publicly available as far as I know. And I wanted to use that module to kind of generate the Terraform code. Right, so it's going to do the same planning steps. It's going to figure out which tools to call, how to kind of work through the workflows. And then it can also validate. So it's running Terraform init right now to kind of make sure that we initialize Terraform, format it, validate it. If there are any errors, it kind of loops through it. And you can kind of see because of that backend, it's actually running Terraform init in HCP Terraform. So the initialization happens in HCP Terraform. So next, we're running Terraform validate and Terraform format to kind of go through that workflow, kind of proceed. And soon we'll also take a look at, running Terraform plan. So if you find any errors, the AI engine can kind of resolve some of that. So quick look at the code that it generated. It generated the proper backend. The module that it used was actually from a private registry. It wasn't from a public registry. And it queried the Terraform Cloud Enterprise repos for my AKS module. And then it got the details of that module, including inputs, outputs, descriptions, any custom readmes that you might have. One essential thing is also the pinned version of the provider. So that module works with that specific pinned version of the provider. So it figured out that, okay, I need to use that specific pinned version of the provider to make this module work, because we can have a lot of mishmash in module and provider versions. So it's going to the next step, running Terraform init and plan for you. And I think this time it did a good enough job that my plan actually succeeded in the first try. In other times, I've kind of seen it struggle and kind of loop through some of the errors and figured out, okay, I need to change some of these things and kind of move forward with that. Cool. The Terraform plan finished there. I just wanted to have a quick slide about why MCP servers are generally better than raw LLMs. You have more accuracy, you have the proper schema, you have up-to-date samples, data, I kind of talked about it. You also have better recommendations. If you're new to Terraform, if you're new to the registry, you don't know where to start. You don't know which modules to use, how to kind of go about it. It kind of gives you really good recommendations on that. And then also it can execute a lot of Terraform workflows for you. So like workspaces, variable sets, it can automate all of those processes for you. All right, so that's it for Terraform. Let's move on to the Vault MCP server. So I'm very happy to say that we made our Vault MCP server publicly available now. So the source code is available, same as Vault. And it's also available on Docker Hub. So you can kind of check it out. We did a private beta release with AWS Marketplace a month ago, but now it's open for everybody to kind of try out. We got a bunch of good feedback from customers, and I'm hoping all of you guys kind of give it a shot. So what are some of the tools that we've implemented for the Vault MCP server? Here are some of the tools. The MCP server can look at your secrets, read secrets, write secrets, delete secrets. It can issue certificates, so we also support PKI engine. If you're a Vault operator and you want to automate a lot of your tasks, you want the MCP servers to kind of do the mounting operations for you, like mounting a backend or secret engine. It can do those operations as well. So here's a quick example of that, right? In this example, I'm asking the AI agent, I've used some insecure way to store secrets in my code. Can you put them under a specific mount? Like, it's the same philosophy. Let's look at what is the thinking of the LLM using the MCP server. So the first thing it thinks about is, does the mount exist, right? I'm talking about a specific mount, and does that mount exist? If it doesn't exist, and if it has the capability on the Vault token, it can create those mounts. If it cannot, it will fail out, and that's the end of that, right? But then if it's able to create the mount, then it understands, okay, this is the path where I need to kind of store the secret. Once it does that, it combines the results and update the code that I have running in my VS Code. So let's look at the demo for this MCP server. So again, starting with VS Code here, I'm going to start with scratch with this one. So I just said it, okay, create a new application in Node.js that allows me to upload files to an S3 bucket, right? Now it's creating an app from scratch. It's a very simple app. It does like very minimal things. The LLM is going to go out there and find out the code from the internet and kind of figure out where to use what. And one of the things that it's going to do is use environment variables for the AWS credentials, right? I mean, that's the most straightforward way to get started. That's very easy to kind of up and start. So what I'm going to ask next is, instead of using this, the environment variables, why don't you help me store these keys that I already have in Vault, right? So just use Vault for those storage. So again, the same set of operations that we saw earlier. It's going to figure out, do I have mount for that already? If not, it's going to start creating those secrets. Now here's the really cool part, right? Once it stores the secret, it understands like how Vault works, and it actually made changes to the code. So instead of pointing to instead of using the environment variables and kind of using those to run your program, it actually uses Vault to kind of do the same thing. And it's generating the README, kind of finishing up with the process. Let's let it finish. I got tired there for a second. It's like, do you still want to continue? So at last, it's like it generated out like all the readmes and how to use it, and even also like if you want to put like real AWS credentials, it gave you instructions of how you could do that. Because right now, it just created a placeholder. It didn't know what your credential was. It didn't know like what the real keys were. It was just a placeholder. So it gave you a CLI command of like, hey, this is how you can use your real keys to kind of store that information. So if we look back in Vault here, we can see that it stored the secrets, in the right path. Not only did it figure out that I need a different path for the bucket name, but a different path for also the credentials. So that's the power of Vault MCP server. Do give it a shot. Let us know what you think. The repository is open. So if you have any issues, just create an issue and let us know what you think. Next, I'm going to talk about the Vault Radar MCP server. So if you should be familiar with Radar, but if you don't know, it's our secret scanning tool. So if you have secret sprawl problem, if you have secrets being leaked in like different environment, people share passwords, things happen, it can detect those secrets that are out there in the wild. So one of the first question is, okay, why do we need like a Radar MCP server, right? In my mind, Radar is one of those tools that kind of act as a seam sort kind of operations, right? It feeds in a bunch of information from a lot of different places. So you have a lot of information coming from, let's say, GitHub, AWS, or Azure, or all of these different places. Like, how do you make meaningful decisions out of that? Where is my priority? How do you figure out, okay, this is a real problem that I need to solve today, versus this is a problem that I can wait to solve like in a month, right? And yes, the UI is there, the API is there, but you have to understand how like all of these systems work to kind of query those and figure those out. With the MCP, you can do the same thing just using natural language, and we'll see that in the demo. Like it'll be very, very easy for the MCP servers to kind of quickly give you insights into all your secrets in a matter of few seconds. So how does the authentication work? So you have your HCP service principal that you probably already have for HCP portal. I use the same prompt string example for putting in my project ID, client ID, and client secrets. And one other thing that I forgot to mention earlier is you can define which one of these fields are password protected, or they can be, in clear text. Cool, let's see this in action. So I have my MCP kind of running on the left-hand side. I'm gonna ask it, okay, how many GitHub resources do I have? Now, keep in mind, I didn't even say in Radar or mention Radar. It was smart enough to understand that I have an MCP connected to it. I'm talking about like Vault Radar. So I did a bunch of queries using the MCP server. I figured out, okay, I have about 800 total GitHub resources across 10 GitHub data sources, right? And you can see there's a lot of like query options, filter options on how you get this information, but the LLM was smart enough to understand, okay, which one to use. And the next thing I'm gonna ask it, okay, I have a lot of repository just in GitHub, we're not even talking other sources. How many of them are actually actively monitored, right? So it used the flag that we've already kind of defined and said, is it monitored? And then it was set to true. And it figured out, okay, only 10% of my repositories are actually monitored, right? And the next thing I'm gonna ask it, okay, what are my top priorities? What is the top 10 things I need to fix right now, right? And so it's gonna run the tools again, and can figure out, okay, critical security risks, here's all the things that you immediately need to fix. By the way, this organization is super insecure. I don't know who's running this stuff, but it's super insecure. And it tells you like, okay, here are all the applications that you have in your portfolio that you kind of need to like immediately resolve. So again, Vault Radar MCP server, we have it available in Docker Hub. You should try it out if you are a Radar customer. Give us feedback how that kind of works. I have a few general points around, this is my final slide if you want to kind of try out any of the MCP servers. I have a few general points around using MCP servers in general, specifically HashiCorp MCP servers. If you are not getting the results that you want, if you're not getting the exact workflow that you want out of the MCP servers, you can define instructions files. So I showed an example of agents.md. You can define those workflows in agents.md file. We've also enabled like dynamic tooling. So if you don't want to give us your token, if you just want to work with public registries, you could do that. There's also defined ways of forcing MCP usage. So in VS Code specifically, if you type #terraform, it's going to use the MCP server that's defined in that to kind of force it to use it. Those are some general advices, and yeah, that's it for my session. Thanks for joining, and thanks for sticking around. And yeah, thank you.